Hey guys, welcome back to your second beginner C programming tutorial. Today we're going to actually run our first code, and here's today's agenda. We'll be running our first code in code block. I will also make sure that I'll dissect the program line by line just to give you insights on what each line represents and why they're there. Okay. From this procedure, I'm going to transition into the concept of variables, mainly about their name restrictions as well as their conventions. And of course, like every other lectures, we'll conclude the presentation with a brief review. So let's go ahead and run our first program in code block. Now go ahead, open up code block. What we want to do is create a new project. To do so, you could click on this little icon where it says create a new project, or you could access it from the very top corner, the left corner, file, new project. So we're going to be creating console applications. So every time you open a new project, go ahead and click this little icon, console application, and go and select C, of course. Next. Now the project title, you could name it whatever you like, but what I'm going to do, I'm going to name mine lecture 2 C dive. Okay. Now this lecture 2 C dive will be stored in a folder called YouTube C series, which is located on my desktop. I just created this folder. So for future tutorials, all my lectures will be stored in this little folder here. You could create your own folder and store all the lectures inside it. Click next and leave everything default and finish. Okay, so to open the source file, we need to expand it. So click on this plus sign at the left hand side, double click on main.c, and you see 8 lines of code presented in the center display. Okay, so every time you create a new project, by default it automatically gives you these 8 lines of code. Before I dissect the code, let me just show you how to build it and run it. At the very top you see there's 2 green arrows. The second green arrow says build and run. This is what you want to click on, or you could go ahead and access it from the build menu, build, and where it says build and run, or F9 on your keyboard. So go ahead and do that, and the results are presented in a console. Black console here, it says hello world, and that's what we printed here. So to exit this console, go ahead and click X or any key on your keyboard. Okay, you can actually modify the text if you like. So let me see. Got 1 dig. So every time you create modification to your source file, you need to rebuild it and then run it again. Okay, so to do so, what you want to do is build and run. Don't click on this guy here because it's not going to compile your modified source code. So go ahead, click build and run, or F9, same thing. Okay, see, this is hello, I just got 1 dig. So go ahead and exit this. Right below is where you see the logs. So if I purposely induce an error, it will display at the bottom, and of course it will give me the location of the error. So let me purposely induce this error by removing the semicolon, and let me rebuild this and run it. And of course it displayed the error. It says expected semicolon before the return. So right here. So it won't let me compile until I fix this error. So to prove that, I'm gonna reinsert this and then rebuild this, and my code is good to go. It ran fine. Okay, now let me dissect the program line by line. I'm gonna start with the very first 2 lines that says pound include. So to do that, let's backtrack a little bit to see what happened with our initial main program here. So basically, before it became an executable file, it was compiled by the compiler here. However, we must note that the compiler itself is not a single entity. Rather, it comprises many other files such as the preprocessor, optimizer, linker, and many other more. But to explain to you the concept of pound include, all we need to focus on is this preprocessor here. So this here, pound include, is what we call the preprocessor directives. Basically, they tell the preprocessor to perform specific actions. Now, one of the common use of the preprocessor is the file inclusion here. So at the very first line, you see include stdio.h, which stands for standard input output.header, and the other one is standard library. So for the very first case, it's telling the program to bring in information to support the standard input output capabilities so they can be accessible to the for the functions that we'll create later, and as well as for the main function. There are many other preprocessor directives, but for now just focus on these two, and in future tutorials I'll have a section talking about the preprocessor directives, a bunch of them. Okay, one last note I want to talk about the preprocessor directives are these double quotes here. Basically these double quotes is indication that it's a common built-in header file. Okay, so suppose you have a very big project and you divide that project into many individuals, and each individual is responsible for creating some sort of functions, and they write their corresponding file. Okay, at the very end you want to incorporate all those files together and you want to combine them. What you want to do is, this is how you initialize it at the very top. You put #include double quotes and the name of that file. Okay, so in summary, double quote means custom built header file. Double arrows mean common built-in header file. Alright guys, now I'm going to talk about the main function. So the main function is where a program starts execution. It's a very reserved function, meaning you cannot have more than one main function in your program. So if you were to create different functions that add, subtract, multiply, and whatnot, you cannot name those functions as main, or else the compiler will complain. Okay, so essentially it contains, inside your main function, it contains a set of instructions that tell our computer to carry out. What do you want to do with it, of course, is entirely up to you, the programmer. So if you were to create functions that add, subtract, and multiply, and so forth, you have the flexibility to call them out in your main function. Just note that whenever you create functions, you have to call them out in somewhere on your program. Whatever you do with it, ideally we want the main function to return an integer. Hence the word int, short for integer, represents the return type for this function, this main function. Normally when you create various functions, you have the function name, but before the function name you also have what we call the return type here. Now there are various return types out there, which I'll discuss in future tutorials when I speak about function. Right after the function name, we currently have a set of parentheses. Inside the parentheses we have what we call arguments. You actually have the luxury to import data from a different domain into this. An example would be World Wide Webbing. For instance, information is passed from one domain and it gets filtered, sorted, and processed in another domain. That's what I mean by that. Now, since all the codes that we'll be writing and reading in future tutorials are from the same domain, we can go ahead and leave this parentheses empty. Right after the parentheses, we have a open curly braces and a closing curly braces. They mark the beginning and ending of the block of code that is inside the body of the function. Inside the body of the function, currently there are two statements inside here, this guy and this guy. Both of these, notice they terminate with a semicolon, which is a requirement in C programming and many other programming languages out there. So don't forget this semicolon, or else your compiler will complain. If you don't believe me, I'll show you right now. Let me take this out and try to compile it and run. And of course it'll give me an error like I showed you before. See, it says expected semicolon before the return. So let me go ahead and reinsert this guy and rerun it, and yeah, sure, it should run fine. Okay, now I'm going to talk what's inside the main body. So let's start with the first command that says printf here, this statement here. Like many other programming languages around, there are various ways of displaying a set of desired data or results. But in C programming, printf is our standard way of displaying output on the screen. Okay, so let me show you how to use this printf to display some type of text. So go ahead, type printf followed by parenthesis, and of course end it with a semicolon. Inside the parenthesis, let's put double quotes. Now within double quotes, let's put some text. So by a noob, and let me go ahead and run this, compile it and run it, and here's the results here. Hello world, I just got 1D by a noob. Notice you might ask, how come I don't see the character N at the very first sentence? Basically, the \n is what we call an escape character. It allows us to get to a new line and start fresh from the beginning of the line. So it moves our cursor down to another line here as shown. That's why you don't see this by a noob on the same line. So if you want to display both these on the same line, just remove this \n. So let's remove that and we'll see. Of course, F9 or build it and run it again. Here it is. You see both of these are presented on the same line and not just limited to one. You could put like N and then, you know, run it again. Of course, it shifts it all the way down here by 4 spaces below. Finally, let me talk about this return 0 statement here. At the end of our program, we return a value from main to the operating system. This return value is important as it can be used to indicate whether a program succeeded or not. A return value of 0 basically means success. So let's run it and see the output here. Notice down here it says process return 0. That means you have succeeded. There was no error during the compilation process. Alright guys, now we're going to move forward talking about the concept of variables. Recall back in math, you could use variables to represent numbers. Well, similarly in programming, you could also do that as well. You use that same analogy. So you might let x be 10, y be 5. The only difference here is that you have to explicitly tell the compiler what type of data is your variable. So here in this case, x being 10, and we know that 10 is integer, so you have to go ahead and type the word int, and this also goes for the case of y. Okay, so this process here is called declaring and initializing your variable. Notice both of these ends with the semicolon. So basically we're telling our program to temporarily allocate some memory for the value 10 to be stored in x and 5 to be stored in y. So now once they're stored, we could use them as we could reference them in our program. You could perform various math operations with them. So for instance, I'm going to add them together, x plus y. So let me just put the answer is, and you have to put percent I, which stands for integer, and put a comma right after the double quote, and then you could put x plus y or x minus y or x multiplied by y, but let's do x plus y. Now this x plus y will fulfill this percent I here. It's percent I because x is an integer, y is also an integer. That's why you have to put percent I. So let me go ahead and run it and show you the answer. Here it is. The answer is 15 as we expected. Be very careful when you name your variables. There are some limitations to naming those variables, and today I'm going to talk about some of the limitations here. So for the first case, the first character has to be an alphabet or underscore. So here you see that pencil is my variable and it's good to go, but on the second case here is a digit, and basically this is violating the first rule, which if you have this as your variable, the compiler will complain and won't let you compile. And then the second rule is that all succeeding character must be letters or digits. So here this is fine, but in this case there's a special character here, which the compiler won't let you do. The other one's no two successive underscores are allowed because this is reserved only for system usage. And one of the major limitation, of course, is conflict with the reserved keywords. There are a bunch of them as shown here on this table. Of course, under any circumstances, do not memorize these, because as we progress further in our tutorials, you'll understand why we won't use them. But for now, let me show you how to detect them on CodeBlock. So open up CodeBlock again. Notice if you were to use one of the reserved keyword as your variable, the compiler will highlight your variable to be blue. So if switch. See, notice these variables are reserved keywords and they're highlighted in blue. That means the compiler will complain if you try to compile it and run it. See, there it is. To help alleviate the problem, we normally follow a set of naming conventions that most C programmers agreed on. So you want to begin your variable name with a lowercase letter. You want them to be meaningful. For instance, if this is how you declare your variable names as such, how I would do it is as follow. First, lowercase followed by uppercase, lowercase, uppercase, lowercase, uppercase. Notice all of these are consistent versus a mixture of these lowercase and uppercase. So whatever conventions you follow, just be consistent. That's all for this tutorial. Please don't forget to subscribe to my channel. Thank you very much. See you in the next tutorial. Bye.